Okay, I'm going to go through some Ohm's law and power calculations. This is the worksheet that we had the other day in class. So, reminders about what Ohm's law is. Okay, this is our relationship between voltage, which is V, current. Remember, current's kind of weird. It's got a symbol of I, and then resistance is R. And if you um, think about a circuit. Okay, so we've got our circuit with our battery. This is our voltage. Okay, this is what gives our electrons a push um, through potential difference, through basically like potential energy to go around our circuit. And then our electrons are flowing around our circuit. I'm just going to draw a really simple one with one resistor. Um, and that is our current, which is our flow of moving electrons. And then our resistors they slow down this current. Okay, they provide a way to slow it down, to lower it. So resistors lower the current because the more of those you have, the more your electrons have to slow down to go through them. Okay, so that reduces the amount of current. So we've seen that if we increase our voltage, we increase our current. If we increase our resistance, we decrease our current. So, and this is an equation where I've shown you all that if you like the triangle method, it's helpful because it's a quick way to look at what am I solving for and what do I need to do? Do I need to multiply? Do I need to divide? Because this is just a 3 variable type equation. Okay. So I'm just going to go through in this video probably the first 4 examples here. Okay, so first one, how much current flows in a 1,000 ohm resistor when a voltage of 1.5 volts is across it. So I'm given resistance and I'm given voltage. I need current. So I'm going to use this equation. I'll just use a triangle while I'm doing these. So I need current, so that means I'm going to divide voltage by resistance. I'm just taking the same equation and solving. In this case, I'm solving for current, so I'm divide both sides by R. So current equals voltage divided by resistance equals 1.5 divided by 1,000. And that gives me 0.0015, and that is amps. Remember, voltage is in volts, current is in amps or amperes. Capital A is our symbol there, and then resistance is in ohms, which looks like the horseshoe. That's omega from the Greek alphabet. So, okay, another one. What is the resistance? So I know I'm going to be looking for R of a bulb filament if it draws a current of 0.5 amps. So that's given. And it's plugged into a 120 volt circuit. So my voltage is 120. So look back at my triangle. If I'm solving for R, now I've got to divide both sides by I, by current. So R equals V over I equals 120 divided by 0.5. And that's going to give me 240 ohms. So that's the resistance of my bulb. My current's got to pass through that bulb when it's plugged into a 120 volt power source. Okay, let's see. Voltage is what voltage? So I need voltage is applied to a 4 ohm resistor, and the current is 1.5 amps. So this one is our simplest example because we're looking for voltage, and all we have to do is multiply current by resistance. So I've got 1.5 times 4 gives me something. 6 volts. And one more example, what's the resistance of a frying pan, okay, that draws 11 amps of current when it's connected to a 110 volt circuit. Okay, so resistance, we don't know. Current, 11. Voltage, 110. So going back up to the triangle, I'm going to divide voltage by current. I'm dividing both sides of this equation by current. So 110 divided by 11 gives me 10 ohms. Okay, so just a few examples. If you just got a straightforward Ohm's law calculation, you're just using this equation, and you're either going to be multiplying two things together or you're going to be dividing two things, depending on whether you're solving for current or you're solving for resistance. And if the triangle helps, I would definitely write that down on your scratch paper or anywhere else where you need it. All right, the next video I'm going to talk about the power questions that are on the second part of this sheet.